Hello class, this is a video tutorial on logarithmic functions. So, logarithmic functions are those of the form f of x log base a of x. The base of this can be absolutely anything, and these are called, well, logarithmic functions. The critical points of the function are as follows. There's an x-intercept at 1, 0. And the reasoning for that is, let's get into the definition. So if we have log of, let's just have log base 2 of x is equal to 0. Well, if we consider what this means by the definition of a logarithm, the rearrangement of this becomes 2 to the power of 0. So the answer of this becomes the power is equal to x. Well, anything to the power of 0 is 1. Hence why log of 2 equaling 0, so if we let y equal 0 in this case, it will always be 1. And this is true for any base. Oops, sorry, let's go back here. The asymptote is at x equals 0, or that is also the y-axis, which means there is no y-intercept. As a result of this as well, the domain is x is greater than 0, or we can say from 0 to positive infinity, not including 0. Let's do some reasoning of this again. So let's say we have log of 2 again. Let's just start with just log base 2 of x is equal to n. If we let x equal 0, this means 2 to the power of n equals 0. What to the power of 0, what to the power of n is equal to 0? Doesn't quite make sense, does it? Because 2 to the power of something means 2 to the power of 1 is 2. 2 to the power of 0, well, that's 1. 2 to the power of 2 is 2 times 2. 2 to the power, even 2 to the power of negative 1 is 1 over 2. Okay, so nothing, anything to the power of something will never give me 0. So this actually does not exist. You can try it in your calculator. Log base of anything equals 0. You will get a math error. And the last feature is that the range is all real values of y. So from negative infinity to positive infinity. Now, just going into more detail about this. The negative infinity makes sense because that goes off to negative infinity. However, what's not as clear is this curve here. It looks as if it's starting to flatten out, which it actually does flatten, but it's always increasing by just a little bit every time. Okay, so the rate that it's increasing, so it's getting more and more flat, but it will never be completely flat like this, and it will just keep on going off to infinity. Oops. So the shape and features are the same regardless of the log base. So if it was log base 2, log base 5, even ln of x, which is log base e, the shape of all of these will look approximately the same with a few minor changes. The transformations of the function, as we've seen before with the exponential function, are as follows. If we let f of x, if we let x be negative rather than be like this, it would have reflected along the y-axis. There's still that asymptote because log base anything of 0, so log base of anything of 0, this is undefined, so we don't know what this is equal to, hence an asymptote. If we reflect along the x-axis, Now remember, it used to look like this. Notice how it's now reflected along the x-axis. Again, all the features change accordingly. A vertical shift, so the original x-intercept used to be like this, but it's now moved up the value of k. And also this one here, if the original function looked somewhat like this, with the asymptote at 0, it is now moved to the right by the value of c. I'll actually get into this in the next video and demonstrating to you what this would look like using the GeoGebra for this. Note, while it's difficult to sketch these by hand, we should better understand the general shape of the function and how the transformations may affect the critical points, as well as the domain and the range. For this example, I'll demonstrate to you how you might graph by hand a logarithmic function. Now, with so few critical points, a table of values is necessary. And yeah, a little tip: the intervals of x, so what these go up by, should be multiples of the base. So if we have log base 2, it's best to go up by 2's. And even with numbers less than 1, it should still be factors of 2, so half, quarter, etc. So if this was log base 3, this would be 1, 3, 6, 9, 12, 15, etc. And the same going backwards, so this would be a third, this would be a sixth, and so on. So let's demonstrate how we might graph this. Now, for those of you remembering about logarithmic functions, well, just logarithms in general, we don't have a button of log base 2 on the calculator. So we actually have to already change this function to so that it will suit our calculator. So it'll be f of x equals log base 10, that button that we have, of x over log base 10 of 2. So this is the only way we can input values of base 2 into our calculator. So you can work alongside using your calculator. You can check here alongside. I hope you remember log of 1 will always be 0. So now let's start testing these values here. So we have log of 2 over log of, well, 2. That's equal to 1. Let's remove the 2. Let's put 4. So now we're changing only that value there. This is equal to 2. Make it 6. 2.58. 2.58. Let's make it log base 8. That's equal to 3 and 10. Oops. 10. 3.32. Let's go downwards towards the fractions. Oops, shouldn't have to do this. So log of a half over log base 2. That is negative 1. Let's delete this. Put that as a quarter. That's negative 2. Okay, so this is enough for me to be able to graph my function, or at least sketch my function, sorry. So let's input these points. X is 1, f of x is equal to 0, so x is 1. F of x, or the y values, are at 0. So my first point is here, 2, 1, 4, 2, 6, 2.58. So 6 is here. 2, that's 3. 2.5 is approximate. Let's just say it's about halfway. 2.5. 8 is going to be at 3. And at 10, it's going to be at 3.3. So 10 is at 3. That's 3.5. 3.3. Hang on, let's get a bit more accurate. That's 3. That's 3.5. 3.25 is about halfway. Let's say it's about there. For a half, this is where it gets really tricky. At a half, it said it was at -1. So half, -1. At a quarter, it's at -2. So a quarter is halfway between half and 0. So it's even tighter here. That's at -2. I hope you can kind of see the shape that's taking form. Looks somewhat like this. Very difficult to do this by hand because it's nowhere near as straightforward as our other functions. So we should just, there we go. Let's give it a label. F of x equals log base 2 of x. So I hope that gave you an insight in how you might graph a logarithmic function by hand using a table of values. Hope to see you in the next video. Best of luck.